Hello, everyone, and welcome to the Impractical Machinists Podcast. My name is Patrick. You can find me on Instagram as @JobShopperTN.
I'm Cameron from Machining is Cool.
I'm Bradley with Marvel Machining.
On this episode, we're joined by Chris Zappettini, the owner of Zappettini Consulting. Chris travels across the United States, giving his expertise to help machine shops and manufacturing businesses sort out their processes. Today, we'll get his story on how he got into that line of work. Chris, how's it going, buddy?
It's good. It's a beautiful Sunday. I can barely see me because there's so much fucking sun coming in.
Right.
How many podcasts have recorded today? This is the first one today, third of the week.
Mr. Popular over here.
Yeah, right?
It's just a interesting timing, you know.
What's it like being famous?
How relax. Okay, relax. Niche micro celebrity on the internet. Come on.
Anybody asked for your autograph yet?
No. Probably the closest thing that was very bizarre was people coming up to me at IMTS wanting to take a picture.
Oh, really?
That was weird. Yeah.
You guys know who I am, right? Yeah.
I'm sure plenty of people that are listening to us or watching us, that they know you from Within Tolerance. So
yeah.
If you haven't, be sure to check that out. It's a really good podcast.
It is. Are you officially a co-host of that, or kind of like?
I think, I suppose, yeah. The format currently is we do the catch-up episodes. So I think he introduces me as the catch-up co-host. So every other episode I'm on, and then every other episode he does an interview.
Okay.
And we've done some interviews together. With Jason Peterson or James Mayette. James Mayette was a really good one, but for the most part, it's a solid format. And then we do, we'll probably start doing more of them again, which is the book club.
Cool. So where are you at in the world right now?
I'm in the Bay Area, California. We're doing some process improvement stuff. It's essentially a little bit more than a week-long jobby. For a project that we were working on a year and a half ago. And that was we had worked on it for a couple months. So it's kind of interesting to come back into it having already done a lot of the work, but we changed some parameters. But it was the weirdest way that a project has ever stopped for us, because their customer was ramping, doubling in anticipation of launching satellites. And then the first satellite launched and was a total loss. The solar nets failed to deploy, and so overnight the demand went from double to nothing, literally nothing. And now it's finally starting to come back.
Yeah.
And as time has gone on over the last year and a half, pretty much everybody involved with the project has moved on to another company. So they asked me if I wanted to come back in and give it another shot. But we changed the parameters from before we were trying to cut it. The way they cut it now is they take the 6061 and take it down to T0 from T6.
Okay.
Because this place also does all their own brazing. And so when you braze T6, it comes out T0, right? So they just start at T0 to eliminate it moving. And the way that the shape of the part, it's long and skinny and thin, and half of the material gets removed on one side, so it bows in the long axis or in the short axis like a rainbow, which is weird. And very different, because you're normally used to it bowing like this, but it bows like that. And so when it's in T0, they can bend it back into shape and then take it to the CMM, because you got a 2 thou wall profile. If the part bows 4 thou, you're fucking cooked, you know?
Right.
So they bend it back. I mean, at the end of the day, it's kind of hilarious, because once it's brazed, the brazement grows 15 thou. So the wall profile, they try and keep that as tight as possible, so to account for it growing / shrinking, but it's almost nothing. Once it's brazed, you can't fucking measure that thing at all. And the only way that if it works is by testing the RF of it.
Yeah.
But so we were trying to do it in T6, which has like a lot of advantages in that it's not as gummy. Like it's weird to think of T6 as the hard material, but like T0 is so like when the part is done and in T0 you can just fold it in half. Like it's
Oh,
like nothing. It's 182 thou thick, and yeah, like with the 20 thou floor, you can just like fold it up. I have a picture. I'll send it to you guys. Of like the former COO who would get fucking really jacked up, and he just crumpled this thing. It was like it's like this big, and it's hilarious. So we were doing it in T6, which like it cuts better chips. You can deburr it easier. You can run a lot faster. But like once it bows, if it bows, then you can't get it out. You're done.
Yeah.
So they kind of like they were where we had left it off is like deciding what to do, but then the satellite failed, and so then the project died. So now we're doing it again. We just decided we're just gonna do it in T0, keep all the same tooling that we had before, and see what we can get out. And we took the one from like 15 or 15 and a half hours to 10 and a half hours, and then the other one from like 10 and a half hours to 7 or 8 hours.
nice.
And that's the whole process. So it's pretty decent. It's not bad. They're pretty like so far they're pretty stoked, and that's been like over like the course of this last week is just kind of programming and going through all these parts, and then it's been really good. It's been a sick week.
Sounds like
When you
a lot
have
of trial and error involved in getting those parts to work.
Yeah, big time.
when you're shaving time off a job like that, what are you shaving it off of? Machine time, programming, everything, or
It's machine time. And
Machine
so the biggest change that we made that had the largest impact was they were using ER16 Farion collet holders, and which are good, like they're very good, like and concentric, and they're like size on, like the whole thing is they're size on collets, and they're well balanced holders. But ER16 just isn't very rigid.
Right.
And so we changed from that to PG25, the power grip. And we also changed the tools from RobJack, which are good tools. Those probably would have been fine, but we changed those from RobJack to the Frasia, uncoated, just like sharp as fuck end mills. And that was the PG25 was the biggest difference, because they were like, hey, we don't want to spend they were like, we don't want to spend the money. Can you just like try it with the Farions? And like the end mills broke like instantly. They just did not take it. And then the last bit we did was going to the coolant flush collets on the Frasias, around the Frasias, so that we're getting like every rougher and like the small little finishers, we're flushing around the shank of the tool, so we have really good chip evacuation. So we've cut all that cycle time out, and have had we might have improved the tool life as well. And so like it's changing the tool, which allows us to go faster, so that we're finishing faster. We're getting better better finishes, better dimensional accuracy, and better tool life. So pretty good.
Yeah.
And yeah.
when you come into a company like this, do they typically have a budget they give you, or what they want to change?
I ask, if I were to do this project today, I probably wouldn't have changed the tools right away, if I'm being honest. Anymore, like this project actually changed a lot of my philosophy with the project going forward, and like thinking about the company more holistically, and like everything, as opposed to just zooming in on this one machine, this one part or family of parts, where I have often, like, there are a bunch of ways to skin a cat, and there are some ways where it's like, oh, well, we can shave a fuckload of time because the way they're doing it now is it's 6 parts. They run the first part complete, the second part complete, the third part complete, all with tool break checks and everything in between. I think with all the tool break checks, that's 45 minutes right
Yeah.
there, And so the last time we were going to run all of them, we're going to face all of them or rough all of them. We'll finish all of them. And that'll save a bunch of time. And it did save a bunch of time. But it was a philosophical thing with how, and like an approach thing, that it was so different than what the guys were used to. It's like, well, if a tool breaks, how do we restart on the third part? We don't want to restart from the beginning. And so like we start building in logic, like with macros and things to make that happen. And at the end of the day, like kind of what we were talking about before with like activation energy and things, is that it doesn't matter to a certain extent if it's better or not, like strictly better. If the guys don't like it, it's worse, period. And so so to keep things as similar as possible is something that I now do, like all the time. Like I did a job in Southern California where we took a part off of it was a 5 operation vertical part and put it on a horizontal, and did it in 2 operations instead, and then ganged it up where we had 8 first ops, 8 second ops on a single tombstone. And like I used their Mastercam program for the most part, just with modifications to make it faster. I used as much tooling as they already had in the machine, and like that that they're already used to, so that there is so little happening that's different. It's just like very, very slight. Cause like at a certain point, there's like the unspoken like ego of it all, where it's like this somebody worked on it, and it's like I'm coming in and just saying like fuck all this and just sweeping it away. Has a has like a really massive impact on like whether or not a project is going to be successful.
Right.
And like getting the guys to buy in, the guys on the floor, like management almost always buys in, Obviously they're bought in because I'm doing it. And like, there are certain managers who will take the approach of like, whatever you want to do, like we'll make them do it, but that's bad and wrong. Like the right way it's like a pincher move from like top down and bottom up to be successful. So like getting buy-in from management, obviously I have that because I'm involved in the project. Now I need to get the guys on the floor to be in line with what I want to do. And that's how projects get successful.
Yeah, that's a smart way to put it, Chris, because I've seen it even internally. Like at my last job, I've seen people come in and make big changes out of the blue, and then the guys on the floor don't like it. Even if it is, like you say, in theory, better. If the guys on the floor that are running the machines, making the parts, don't buy into it, they're going to fight it. And so that's pretty wise.
And machinists hate change, especially if stuff can head away for
big time
programmers.
Yeah.
Guys that set stuff up. And even just, do you get any pushback trying to bring in tooling to companies if they're...
Yeah, that's why, like I do a lot of work with RegoFix and Shunk, and from like the holding aspect of it, and then like Frasier, kind of Destiny a little bit, and like some other guys. But the easiest way to get buy-in is if they don't have if they don't have to pay for it, no fucking problem. Like if I'm just bringing in a tool and a holder and it's like I'm programming it, I'm gonna make this work, nobody's saying anything. But if you like drop an end mill off at somebody's shop and they're like, oh, try this is good, they'll be like, okay. Then you could go in there like a month, 2 months later, I haven't gotten around to trying that yet because it's different, And like
me bringing it in, putting it in the machine, showing them what it can do is proven that it's worth the cost.
Yeah, you kind of like you want to believe that people will do the right thing, and not saying that it's a bad thing to do that, but a lot of the time it's just everybody's busy and you're going to default to like the safest thing you can do, which is like just I need to make parts right fucking now. I don't have time to like play around and like try this end mill out or whatever. But if this other guy comes in and he makes it happen for me, then it's like, oh, cool. Then like, like not this could be a little derogatory or whatever, but people like to think they're a lot more creative than they are. And they can't, like, I've run into this a lot, which is like, oh, I'm so open-minded. I'll try anything, whatever. But then you tell people about something and they're like, well, I can't fathom how it works. So it obviously doesn't work.
Yeah.
And it's just
Mhm.
something that I picked up when I was doing applications for methods, is I would create these like macros that made the machine a little bit easier to use, like which I found like you do independently of like realizing like, oh, Matsura does this or whatever, is like you have like a G100 or a G150 as a tool touch a custom G code to touch tools off, and you tell people about it. They're like, no, I don't. That's fine. I don't need it. But if we just put it on and show them how it works, then they use it.
Well, on that note, you mentioned, your time with methods. I'm curious. I mean, as we always ask our guests how they got into machining to begin with. So if you
Yeah.
could kind of give us the high level view of how you went from getting in to being a guy that goes around telling people how to run their shop.
Yeah. Well, that's just because I have like insane confidence in myself. I don't know what
There
I'm
you
doing.
go.
I just think I do. But like I didn't do anything like mechanically like growing up, really. I like just played video games like all through high school, and then I was kind of like, oh, cars are neat. Didn't work on them or anything. I was just like, I went to like some, I don't know, like some college thing, like while I was in high school. I was like, oh, FSAE seems cool. So I started applying to schools that had automotive programs. And like most of the ones that I wanted to get into, I didn't get into, but I did get into ASU, which was like truly like I would not be where I am right now if it wasn't for ASU. If I went to the schools that I'd wanted to go to, I'd probably be some fucking nerd in spreadsheets all day. And but ASU is the Haas Technical Education Center. So that was like the first time I'd like even seen a machine really, and was like, oh, this is really cool. And like part of the coursework for the degree for like even the mechanical engineering as an MET, mechanical engineering technology degree, is like we had to take a semester of manual machining and a semester of CNC machining. It was like course requirement from like a DFM standpoint. Like if you're going to be a mechanical engineer, you should probably know how this shit fucking works.
Good.
And so yeah, it was good. That the program doesn't exist anymore, but it was sick when it was going. But I guess quickly, like for younger people listening to that, if that sounds interesting, the guy that was like really in charge of that program, his name's Treon Giorgio. He does not work at ASU anymore. He works at Cal Poly San Luis Obispo in California. And he's the best. He's like the entire reason that I do this, because he was just young and passionate. And that was like infectious. And he really just like, at the time we had a VF2, a VF3, with a 5-axis, and like an ST10, or maybe it was an SL at the time. And he just like, if you were interested, he just kind of let you go. We had fucking SurfCam, the worst cam software of all time. Especially back then, there was no undo, like there was no Control Z. So if you fucked up, you just like, well, I guess I'm starting over. And so like I started cutting, and like that's when I started cutting and just kind of like really got way into it. And so then I double majored in mechanical and manufacturing engineering technology, and that's kind of like I was hooked, my entire career, like, and everything that I did going forward was just wrapped around CNC machining. Like we built our capstone project was building like a 1-to-1 scale model of the Iridium Next satellite for orbital ATK, which is now Northrop Grumman. That was like spatially and inertially 1-to-1, so that they could use it to like test their assembly equipment. And we had like 9 months and like 12 grand to do it. And we machined so much shit on there. And that was like one of the dumbest things we ever did is did like a 12-foot long rail and a VF3 or something. It is so stupid. And we did one, bent the shit, did one that worked out, did another one, it bent because it was so thin, it bent it when it caught the tarp that we were using to keep coolant inside the machine. That was annoying. But yeah, I mean, that was how I got into CNC machining and just kind of really pushed myself that direction. I graduated. I was living in South Carolina doing online work when I graduated. Then moved back to Arizona. Worked at a shop for 8 months. That's where I learned to turn. I had been turning for 3 months or so when I got the job at Methods. And then I don't know, maybe within 6 months, I was on a Nakamura, dual turret, dual spindle machine or something like that. Maybe it was a year, and that's just kind of, and really I've said this a ton on With Intolerance and on other podcasts or whatever, is just that just hardcore advocating for yourself and being very aggressive. That's what really got me to where I am, is I want to do that. I'm going to do that. And not really just saying I want it, telling your boss, oh, I want to do this. And then just sitting there.
Yeah.
Cause that's what a lot of people do.
Yeah.
Is hey, I want to learn how to do this. I want to do that. And then they just expect the company to fucking drag them through it. And it's if we were still in the 60s, maybe 50s, 60s, welfare capitalism, that was the United States, probably you could do that, but now anymore, especially in this industry, nobody has fucking time to just drag you along, and if you aren't going to put in the work, you need to be able to put in the work, and also be willing to as I mean, everybody fucking says this, but it's just be willing to fuck shit up, and know that you're gonna fail. You're never gonna be perfect, so stop trying to not make a mistake. Just fucking cut already. And if you crash, you crash. On a mill especially, you might I mean, you can do some real damage on a mill, but in most cases, when you fuck something up, you're breaking a tool,
Yeah.
you could obviously torch a spindle or a rotary or whatever, but you'd have to be really fucking shit up. But in most cases, from a programming aspect, if your tool comes down to the right clearance plane, more than likely you're okay. At least that's step one. And then if it goes down to the next one, that's step two. And then if you took too aggressive of a cut, that's that. But you snap off an end mill, whatever, try again.
I tell people that all the time. That's why I hit the green button and leave sometimes. It is.
Yeah.
Yep.
If I know that tool comes down right there, the rest of it's good.
Yeah.
Unless, like you said, unless I accidentally hit
Especially
10,000 something.
especially on a 3-axis, right?
Yes.
It's what else could it do?
Yep.
It's not like it's gonna tilt and oh dang. It's the part, the part's the part. It's not gonna move anywhere. You're fine.
The one that catches me, it's been a while. It's probably gonna get me next week now that I say this. Are dogleg rapids.
Yeah. Oh yes.
Hits me all the.
Yeah. On Fanic, that's a parameter. You can turn it off.
Haas has some sort of parameter, but it slows it down and it sounds like the machine is killing itself.
Yeah, it's actively. It's we're not designed to do this. I'm gonna fight these axes. Why would you do this to me?
I tried it once and I think I hit cycle start and came and sat down and I was like, what the hell is going on?
No, stop.
Yeah.
Do any cam systems have a fix for that?
No, I don't think so.
I don't remember which one it was. I heard one has something where it'll actually show it, but you have to have your rapid feed rates and everything in there.
Yeah.
And your machine set up.
Interesting.
I wanted to go back to something you were saying earlier about advocating for yourself to basically actually get somewhere in the industry. So I tell people kind of, I think we're on the same page. I tell people regardless of what industry they're in, what their job is. Like if you want to improve and you want to be good at what you do, you want to excel, you want to moving up or whatever, get big and move on to the next job. You have to take your own education into your own hands whatever field of work you're in. So like if you want to be better at machining, you need to do some research. You need to start, listen to podcasts, listen to other people talk to whoever you can, learn from wherever you can, and go get, like say you're at a shop and you want to learn how to program, but they're kind of dragging their feet and like you bring it up, like you're saying, and then they're like, well, we don't really, have the time to teach you, whatever. Like we can't really figure out how to make that happen for you. Like go get your own seat of fusion. Like go watch YouTube videos, start learning this stuff. I tell people that all the time, but it seems like nobody ever takes it serious whenever I tell them that for the most part. Like it seems like very few and far between people that actually are like, no, I want to learn how to program. I'm going to just figure it out.
You can't fail if you never start. So it just takes that whole aspect out of it. Cause if you've like grown up and like, I don't know, this, I'm going to probably another wild one to say, but it's like, if you've grown up being like, oh, I'm a very special boy and I've excelled at just about everything. So like, you're embarking on, and everything that I do that I'm good at, or everything I do I am good at is like your baseline to hop into something that is like highly technical. And there are a lot of people that are much better, going to be much better at it than you are. It's like embarrassing to not be good at it right away. And so people just don't do it. And it's like, I need somebody to, I do get asked like, oh, did you go to school for this? And did you go to school? It's like, I went to school and I learned stuff, but I didn't learn to be me by going to school. Like school gave me tools, on how to solve problems. And like it was the catalyst for becoming who I am right now. But like most of like how I got good at macros, but was by doing macros, like I didn't get good at macros because somebody like just gave me the knowledge.
Just handed it over to you. I think that's what a lot of people expect. They go to a company or whatever, and it seems like, I don't know, maybe it comes from being in school your whole life before you get into the real world, and like you're just told everything that you need to know. Right? Like they have their own curriculum. It's like, no, you need to know this stuff for this curriculum. Here's the curriculum laid out in front of you. So it's kind of easy mode. You're just like, oh, well, I'll just follow along, and they feed me all the information as we go. Then you get to the real world, and it's not that way at all. Like you have to continuously be a student of what life in general, but also of whatever your trade is. You can't just expect that information to be, transmitted into your brain by somebody else. Nobody really cares that much. So
Right. And like getting started, I think Fusion, like there's a good example of one of my customers in Maryland. They have like a Haverly 5-axis. They just bought like a Matsura 5-axis. And one of the guys there, the younger guy, he learned how to do Fusion on his own and then took that, and they have Inventor because they do a lot of like ITAR, EAR stuff. So they use Inventor for their CAD software. And he just used that to start programming parts, for the 3-axis. And then when I was there for 2 weeks doing like some programming stuff, and they used Mastercam, but I was like, hey, we could probably do this way better in Inventor. We could set you up a little bit faster, a little more parametric, and like tie this into like where your parts are actually drawn. Instead of having to like do this like weird process to like get them in and out of Mastercam. And by the end of that 2 weeks, like with the kid, they went from 2 5-axis programmers to 3 5-axis programmers over the course of like 2 weeks, by getting like all their shit dialed in so that it works with the 5-axis and like building like the system and templates and whatever. And then he's just like ran with it completely. But he did that on his own, like he was like, he put Mastercam on, they gave him Mastercam, but why? And they were like, oh, we'll teach you, but they didn't teach him, like, so he just used what was available to him and what he was familiar with and was just making it happen.
Man, those are the people that I want to hire.
Yeah.
So You mentioned that you worked for Methods. What did you do for them?
I was a applications engineer. So I worked 3 years in 3 years in Arizona, where I think like 2 of those I was the applications manager or whatever. Um, and I would travel the territory and do training and turnkeys on all their products. So that was like Kiwa at the time, like you're familiar with this, like they had Feeler, Robo Drills, Nakamura's, a different Kiwa. Like there was Kiwa Japan, Kiwa Litz, and then
Mm.
I never really touched the Yazdas. Like Methods had like a really weird thing. They still kind of do, where like the 5-axis is like special, and it's just really not. Like it really holds people back, but um, it's like 5-axis, in my opinion, is like the easiest type of machining you can do. Like, but bar none, you just don't have to think about things nearly as much. Like when you're programming like a part that has like 6 sides on a 3-axis vertical, you have to be like very intentional about how you're cutting that part, so you don't like fuck yourself like 4 operations down. You're like, well, how do I fucking hold this now? you know you really have to like think about it. Where like a 5-axis, it's like, well, this this big flat side is going down, and then I'm gonna cut everything else and use a saw and chop this off, and like maybe I have to like put in a soft jaw or something or a fixture and like cut the other side, but a lot of the time you can just like fucking sand it and
Yeah.
call it a day. So it's always funny when people are like very precious about 5-axis, because it's cake.
Yeah.
Mm-hmm. Nice. That's
Go
actually
ahead.
I've gotten a little firsthand experience with that this week because here at my new job we've got a 5th axis on the VF4, and I did one
Cool.
job on it that was, I mean, it was kind of silly to do on a 5-axis. We just did it because of the vice that's on it, but
Mhm.
it started to put in my mind, okay, I see where this is going. I
Yeah.
really start to see where the whole 5-axis thing comes in.
I was gonna say, how'd it go getting started on a 5-axis? Like actually
Oh,
figuring out how to program that and everything.
it was so cool.
Yeah.
I will say Fusion makes it easy.
Yeah.
As
It's
far as
cake.
as far as managing your tool orientation and all that stuff, it makes it easy. Setting your work offsets. Haas having the tool center point control and all that stuff makes it really easy. I mean,
Mhm.
it's like Chris says, it's cake. Coming from
Yeah.
a shop where all I had was the fanciest machine we had our 4-axis lathe with sub spindle, and then we had
Mhm.
3+1 4-axis mills. But coming in here and having access to this 5-axis Haas, it's so cool to see how much easier it is than I expected.
Yeah.
It's really
It's
cool.
funny 'cause
Yeah.
people always make 5-axis work out to be like some crazy
That's what
complicated thing.
Right,
Yeah.
right. I thought the same thing.
When it's
But
like when you're in like full 5, it can be kinda wonky, and like
True.
doing like certain shit,
Yeah.
it can get wonky, but like 90% of the time you're just doing positional 3+2, and it's like, whatever. That's like it is. And like with Fusion, where the Haas post is just so fucking dialed, like you just don't even have to think about it. It just works.
Mhm.
It's nothing.
So if you were an applications engineer for Methods, how long were you with them?
5 years.
5 years.
Yeah, so yeah, 3 years in Arizona. Then I went to Massachusetts, where their corporate office was or is. And that's where like my house is. Like the house that I own is like 15 minutes from that office.
Mm.
I worked there for 2 years, and I primarily did like automation turnkeys on the cutting side. And I like mostly worked on like the entire time I was there, I worked on like 2 projects.
Mm.
Which they were both like big, big like fracking tube, like the guns. They call them guns for popping holes in the casing to get the oil out of the ground, and making those like as fast as possible. Those are some of the most challenging projects that I've ever worked on. Just from like one of them was like a personnel aspect, like the customer was very difficult, and that sucked. The other one was just you just have a lot like the material is so poorly controlled, and it's made all over the world, and they just get it from wherever. That you like from a run to run, you'll get some that's like very gummy and it doesn't chip very well, versus some that's very hard and it does chip very well. Um, but like our challenge was like the chips, the threading chips of like a 3 inch or a 2 3/4 inch 6 pitch Acme thread. It's pretty gnarly. I mean, I made like a peck threading macro so that we could like go like you can bring it in and out and do like every other thread, and then do a straight cut so it breaks the chips up.
Huh. That's pretty cool.
Wow.
And then yeah, because like Esprit and like some cam systems will give it to you, but it's like long code. So if you have to like make adjustments, you'd have to like repost it.
Yeah.
But like so I just kind of copied it. Instead of like a G76, I made it like a G760 two line can cycle. So you could do like upper turret main, lower turret main, upper turret sub, lower turret sub, and just paste that in. It's like, oh, I need to go a little bit deeper. You could just like adjust the can cycle and it would go deeper instead of having to repost it.
That's pretty cool.
Yeah, it was a fun one. That was a fun one.
You actually created your own can cycle.
Yeah. Yep.
How's that work?
It's just super easy. I mean, it's just any macro, but you just assign the program to G code.
Okay.
So like Fanuc has, and like Haas has it too. But there's like a subset of program numbers that are available like and attached to parameters. So like 6058, for instance, parameter 6058 on a Fanuc control is attached to program 9018. So whatever's in 9018, if you attach like if you make 6058 345, G345 will run program 9018.
Okay. That's pretty cool.
Yeah.
I knew that was kind of a thing, but I never actually looked at how it's broken down.
Yeah, and then there's different levels to it on a Fanuc control, because you have like just a G code and just an M code, or you can have G code subprogram, M code subprogram, and the difference is like the just the G code and just the M code are pretty self-explanatory. It's like it's just the G and the M code, nothing else. But like the subprograms you can pass variables through. That's where you get the G760, like ABC 1 2 3 whatever. And it'll just take that, like A is pound 1, B is pound 2, C is pound 3, blah blah blah. And so then you take that information and you just interpret it in the program how you need to.
Okay.
And then I mean, if we want to get like next level, there's like what they call argument 2. Macro will be argument 2, which gives you have A through Z, with the exception of like L, N, O, and M. I want to say maybe not M, but P. You don't get P. L, P, O, N, I think, are the 4 that you don't get. Or you can do A, B, C, and then I, J, K repeating like 10 times. And that gets you to like pound 33. So like you can create like and like you see this on Masters and like a lot of other machines. And like I've done it too, where you like, oh, I want to create a custom custom macro to touch off random tools. So you just use the I repeating. So you go like, oh, G100, I1, I5, I7, I whatever. And then it'll populate like 4, 7, 10, 13 macros, and then just every time it bounces back, it remembers, and then you just go and go and go and go.
That's pretty cool. Sometimes I find that stuff more exciting than actually machining, like learning about
it. Is exciting. It's yeah. I mean, it's the best.
Yeah,
that's my favorite shit. It's like the only thing that I'll be like, I'm good at macros. Everything else, I'm just like whatever at.
Yeah,
that's fine.
Macros is something I'd really like to dive into more, but it's one of those things. It's kind of like we were talking about before we started recording, like with building cam templates, for example. Like you're always busting your ass to get work done. You're like, I don't know, I just need to get the job done. Like I've got shit to
Yeah.
do. I've got too much going on to really sit down and mess with
Right.
it. So
Right.
with macros, for example, there's probably stuff that I'm doing that I can make easier, faster, better with macros.
hmm Maybe. Yeah.
Br-
And sometimes it's like you I always find it like when people tell me like they want to learn how to use macros, I'm always like, "Well, for what?"
Right.
You know?
Yeah.
Like, what's the project? Because if you don't have a project, like you can just read Peter Smith's book and and that'll tell you about macros, but it's
Yeah.
if you don't have it's like learning a language or learning anything. Like if you don't use it, you lose it kind of thing.
Mhm.
And really I just have like I guess a GitHub or a spreadsheet or Google Sheet like that's publicly available that has like a fuckload of macro stuff in there.
Yeah. It's what seems like one of those things where, it sounds like it might be a huge problem solver, but in reality, you may not have any problems that need solved by it.
Yeah,
Not paranoid.
you can create a lot of problems for yourself by introducing macros if your math isn't like really dialed
Right.
in and like your loops get kind of wonky. And that can cause some headaches where like you just start like, oh, it's supposed to retract, but it just I didn't do the math right, so it's just fucking going down the line.
I think my assumption would be like the most common use of macros. Like if you were going to try to learn macros in a shop, the most common use would be in relation to probing.
Yeah.
Oh yeah.
Like if you want to start getting into
Absolutely.
it, that was the first thing I ever did with macros was probing. I was running
Mhm.
a job. I had 6 parts. I was running 6 parts in the machine at a time, op one and op two. They're just like some round, parts that had a fit on them. And so in op two, I wanted to check. Maybe it was op one. Yeah, it was on op one that the fit was on. I just wanted to check one part every third cycle.
Okay.
Probe, but with how everything was fixtured, like you couldn't do a normal like X and Y direction like boss measurement.
Yeah.
So I dug into like the probing manual, figured out like how to do the 3-point measurement, which was already
Mhm.
like so I didn't have to like figure it out, but I wanted to learn what was going on there. And
Yeah.
then did like the basically just a macro parts counter, like pound 601 equals whatever, like 601
Right.
one or whatever. And then honestly, I don't even remember how I went about it all, but like you do like if then stuff to where you'll skip over the probe cycle if that, part
Mhm.
counter isn't equal or is less than 3. And then saving dimensions. This is probably like my favorite thing that I figured out with macro programming is when you look at the output variables in the probing manual,
Mhm.
you can see like it tells you your position, it tells you the measured dimension, like all the
Yeah.
basically any possible bit of information you can get out of the probe is there. So then what you
Yeah.
can do is right after the probe cycle, like I do with fits a lot of times. So your diameter is pound 138.
Right.
So I usually just go to the 600 range because I know that will retain after the cycle. So I'll do like pound 601 is equal to 1 pound 138. So then now that
Mhm.
diameter is saved, and then I can check multiple ones. So I'll just do like a pound 602 is equal to 138. So then you can go back and see all your dimensions from when the program ran,
Right.
and then that's just a quick, easy way for me to keep track of it as I go.
Yeah. Yeah. These guys, I guess, like on that note, these guys, this is something that they had developed before I was here. Like this dude, John James, um, he's one of the best programmers I've ever worked with. And he moved on to another shop where he's doing current things and all still in the Bay Area. But one of the things they worked out with their customer who required 100% inspection but that would just bog down their QC is they do KPI inspection inside the machine with the probe,
Mhm.
and they deprint that out as like a report,
Yeah.
and then put it into Excel, and then run a macro in Excel. So they have like they essentially create like an inspection report with their machine, and then that gets submitted with the parts to the customer,
Yeah.
which is pretty slick.
I've heard of people like printing reports straight off a machine, but I've got no
Mhm.
idea how to even start.
That's just deep print. Like you just look up the deep print stuff. It's really what I like. This is a cool Haas thing is like Haas, you can deep print to the control and like there's like a file on the control that you can deep print to and like go back and look at,
Okay.
which is really sick. on Haas.
Yeah.
On a Fanic, you'd need to do it to like the data server or to a USB or something.
Mhm.
But if what you're deprinting to isn't there, it just fucking bombs out. Gets really upset with you.
Really?
Yeah. Oh yeah.
Huh. Yeah. Seems like there's so many little, like, I guess you have so much insight because you've had so much variety in your career,
Yeah.
and so much problem solving with stuff like that. Like, you don't know what you don't know. So I love talking to people like you where you're like, oh, you just, do a deep print. And it's like, oh, okay. That's
Yeah.
a thing.
Duh.
Nice.
Yeah.
Yeah.
Yeah. Just a deep print.
Yeah.
What are you, dumb? Come on.
So you said you're at Methods for 5 years.
Yep.
Did you go out on your own after that?
No, not then. And I kind of broke up the methods thing too. Like I went and I worked at a company called Plethora, which is like a automated cam company
Mhm.
/ hardware startup for like 5 months. That sucked. I hated that. I met a lot of cool people, I think there's like another practical machinist contributor who used to work there too. His name's Chris O'Brien, the cam factory guy.
Mhm.
He worked there. I met him there. He worked for me for a little while. And that's how I broke that up. And then after that, I was here in California. Like the shop is like right around the corner from where I am right now. And I was there director of engineering for like 6 months. I went there as a manufacturing engineer. And I didn't really like my boss was fine. He just was like over his skis in my opinion and like wasn't very well suited for the job. So I went to the CEO and I was like, "Hey, I think I could do a better job than him." And he was like, "I think you can too." So he gave me his job and then put him in a different role. Um, and that was pretty fine. That was a decent enough job. Then I worked for myself.
All right. What made you go out on
Yeah.
your own?
I had technically started the LLC and like when I quit methods, I was like, because I like doing applications work.
Mhm.
And I kind of always like the thing that I like is I do like to travel. I like being in a lot of different shops. And so I just like started the LLC and was um, like, oh, we'll see if opportunity arises, whatever. And I did a little bit of work in the Bay Area for like some guys that were just starting up. And then a buddy of mine hit me up and was like, "Hey, I have this product as a gun that I need to like get off the ground. It's just a design right now. Do you want to come work for me for like 3 months?" And I was like, "Sure." I was like, I'll do it for like $45,000." And he's like, "Okay." And that was it. Yeah. And so then I've been doing it ever since. Um,
Wow.
and Yeah, it's like and now I wouldn't like, if I were to do that now, that would be like, I don't know, I probably wouldn't charge less than like 100 grand for that.
Really?
Yeah.
So what exactly would you say your company does? I mean, are you like independent applications?
Yeah, I mean, I'd say contract applications
Yeah.
is a good way to put it. Because we do a lot of training. Like I've done I think half the work I've done this year has been just like training exercises. Like
What kind of training?
machine training. Machine training, fusion training, whatever.
Like,
So dealers on the East Coast, these guys, MTA, they're a methods dealer. They'll like they sold a 5-axis to this guy's first 5-axis, and he didn't know. He just didn't know, and he used like part maker, and he's like, well, he was thinking about buying Mastercam to run it, and I was like, don't do that. You bought Camplete, like Camplete comes with the seat of fusion. Just learn like we'll do fusion. And the week or so that I spent with him, the training included like I programmed his first part for him. We set it up and we went through like how the machine works. And by the end of it, he had a part, done. And like I won't train somebody unless there's parts to cut. Like I'm not gonna do it. That's just not like for what it is, like you want me to show you how to use the machine, that's fine. But all of your questions are going to come as soon as you start cutting chips. So we're going to start with cutting chips.
Yeah.
And the like It's so fascinating doing this because like I've said this, like this is like the time number 3 of the week. But it's like I'm not gonna train you how to run the machine without cutting parts, because like the mission of the training is for you to know how to make money with that machine, right? How does sister tooling work on like and tool groups and whatever, like unless this is like machine 456 and you have like a dialed in workflow for this type of process, especially if it's a new process, why the fuck are we talking about that? You know, you don't have 2 sets of every tool. So what the fuck does it matter?
Yeah.
You know, like the mission is to get your parts from the cam system into a box, right?
Yeah.
So like that is what the training is going to entail, and like what we're gonna work it around is doing that. And then if we want to go into the advanced shit, we'll go into the advanced shit. And the Amish guys that I trained
What?
in
Hang
Pennsylvania,
on.
uh,
You trained Amish guys?
yeah, they bought an NTRX, which is like a big B-axis lathe.
I thought they couldn't use electricity.
Brother, that's a whole thing. It's
Aren't they the
it's
Mennonites or whatever?
That's the no, they're Amish. Like, so Amish are they're like, we're not Mennonites, we're not that crazy. um uh they just have like they don't have any like written rules. It's all like verbal doctrine or whatever. So the way that they can kind of like rework the philosophy as times go. So like they they use machines because like farming isn't really a thing like for them in the area anymore.
Yeah.
So they were farmers, but now they can't really farm. And then they'll have like business partners that aren't Amish. So then they're technically buying the machine. And they just run the machines, you know, even the and like they won't have a computer at home, but sometimes they will have a computer at home. And like the kid had a cell phone, but he had a flip phone because he got like shunned for having a smartphone. But the older guy who was married, he had a pager. Um, uh, yeah. And so they were using, he was using Fusion and training on the NTRX, and he wanted to know like, well, how do I do this? And how does the tool groups work? And how does this work? And then it's like, we'll get there. Like,
Yeah.
don't worry. Like, we really need to start
For a
cutting.
horse.
Yeah, literally. Dude, that was the wildest thing is like outside the window of the shop was just like fucking horse and buggy just flying up and down the street.
Oh man.
Once like it was raining, this car was fucking hauling with like a baby, like a calf in the back of it. It was like sick.
What did they think of you
they'll
coming in there with all your tattoos?
Well, they were fine. I mean, because I started like that. I split that, and that was a 1 week training that I split into 2 weeks because I did part of it 1 week and we left them cutting. And then I went to the UK, got my head tattooed, and came back and kept going. They were fine. They're okay.
Yeah.
Yeah. Like I said, nobody really cares about the tattoos so much because like can you do the job?
Right.
Yes or no? And I do the job.
Yeah.
Like some people who haven't seen me in a while, like one of the machine tool guys, he like rubbed my head. I was like, oh, that's interesting. But no, it's fine. But with the Amish guy, like when we started getting into it and then we started cutting, and then he realized like all of the little things to make the program go, like to make the post work and like make sure that the post is good and that we have good code in there and that we have our tools touch off correctly and blah blah blah. All of that supersedes the frilly bullshit like, oh, that like I just keep harping on the tool groups because that was the thing. That's like always the thing, the sister tooling. It's like, do you have it? No? Then we'll fucking talk about it later. You can call me back when you're there. But it's like, this is how it works.
Yeah.
Next.
Yeah, you have to build a good foundation.
Yeah. Yeah.
For
exactly.
Sure.
Yeah. What made you decide to go out on your own, Chris? As far as, you had a good gig and then you decided, okay, I want to be a freelance apps guy, basically.
I it's probably just like a problem with authority, I would say, and just like I like to I like to more or less like yeah, I mean, I like to make my own rules or whatever, even though like every customer is my boss. I don't actually have like that much freedom, so to speak, but like I am like that being said, it's kind of neat that I'm like right now it's a Sunday in California. I'm at a shop that I don't work at. They just hired me. They gave me keys. I'm in an office, and then Tuesday I'm gonna fucking get in my van and I'm gonna drive to Reno and I'm gonna do it for somebody else, you know?
Mhm.
And then next week, the week after that, I'll be in New York, and then that's it. And so like
Wow.
that is the most appealing is like I have really happy feet, um, and I like to solve problems. So like yesterday, like I was saying yesterday, on Friday, uh, Subway called me and they're like, "Hey, like, how do we make can plate go? Like, these guys bought a machine. They need help. They need to ship parts by Monday. Can you go help them do that?" And it's on a Wash-On D2, which is a machine I'm not very familiar with. Like, this is the first. Yesterday was the first time I touched it. Um, and so it's like, sure. I mean, but it's fusion, it's cam plate, which are two things I'm familiar with, and it's a 5-axis FANUC control on a wash-on, which of those three things, I'm familiar with two of those things. So how hard can it actually be? Uh, and we ran into some issues where they were just doing some really dumb shit with their like because they didn't have a probe and they don't have a tool setter. And, like, I walked in, and it was just really weird vibes right off the bat. Like, the guy's like, the machine's set up, we just need a post." And it's like, "All right, relax." And they did set up the machine, but they set it up, like, incorrectly. Because if you're using G68.2, like, you can't have negative tool offsets, and you can't have a positive Z offset in your work coordinate. Because like, when it tilts, it's like all of that that information it's doing math based on the spindle position. Like spindle and like you have a negative offset or a negative value from like spindle to center of rotation in your 19702 parameter. So like when you tilt it sideways and you have a positive Z, now it's going positive from the spindle. So it just fucking was trying to shoot off into space.
Yeah.
And like we were like I was just like we were beating our head against the wall, and then it's like, oh duh. Because I never you just like certain things you just never think about. Like, why would somebody set up a 5-axis machine? But somebody who doesn't know, who doesn't have probes and doesn't have a tool setter, they set up the machine the way that they would normally set up a machine. So then we just rigged up like it's an HSK. So I used 2 1 2 3 blocks and like a height gauge with an indicator on it. And that's how we set our tools as a positive gauge length. And then made it work from there. It was pretty whack and lame, but like by the end of the night, I was there for like 9 hours. They had a part,
Yeah.
you know?
Mm-hmm.
Have you ever been in a customer's facility and crashed a machine?
Yeah. It was fine. Like, luckily, it was fine. Like, it was like the hardest crash I had was on an Akuma where I fucked that thing up. Uh, I like really it. I like to joke that I crashed it so hard I made the machine better because like it brought to light an underlying issue that we had been dealing with the whole time. Um, but yeah, I mean, like I had no repercussions other than like I can't work for them again. But for the most part, most of like that was really the bad one. Other ones are just like breaking tools,
Yep.
you know? Like
Do you have something in your contract that says if I crash your machine, I'm not paying for it, or do you got insurance
I have
coverage?
insurance. I have like $1 million policy or whatever, like liability and like $2 million. I think it's like $1 million business or $2 million business and like $1 million liability. And it's like
Mhm.
$500 a year. It's like totally cheap. It's and worth it.
Oh,
So if you were to crash a machine, blow up a spindle, and they were to come after you for it, you're covered. for
Right.
it.
Yeah. Like
so-
I had a guy break like these guys broke a probe tip and they like I get an email from the COO that's like, I'm not saying we're gonna do anything, but do you have insurance in case we crash? And it's like, yes, here it is, whatever. But like they're a good customer. They were just like
Yeah.
he's just like getting scared or nervous or
Mhm.
whatever.
They're nervous to hire somebody that's probably more skilled than their employees. but they let
Yeah.
them run the machines.
Yeah. I mean, the guy that like they were doing some really like while the machine was in cycle, they were fucking with the offsets and like did some stuff and like it just like it was frozen because of there was a value in the WSEC, which I don't know if you're familiar with the WSEC. Like so, FANUC has this thing called work setting error compensation, which is G54.4, which is designed for things like castings or second op 5-axis work, where it gives you an additional axis to play around with. Meaning, and like then it just compensates with the two rotary axes that it does have to approximate the other axis. So if you're on a BC machine, you can do adjustments in A, and it will use the B and C to approximate your error in A, which is like when we're doing like bolt handles, where it's the part is like in line, the handle is like rotated on the A axis, technically, and we need to like get that into alignment. We probe it, find it, dump it to the A, and then we make like perfect parts that way, which is good. But like part of what that needs to happen is like when you do like certain stuff, you need to have like the rotary unclamped. And if there's a value in A and you're at B0, C0, it's going to move B0, C0 in order to create the A. So then it won't move. So while the machine was in cycle, and this is kind of crazy that it happened, they're like, oh, there's a value in A, and they just hit 0 and it just fucking sent the probe. And it's like, don't do that. Like something was, yeah, it's like that was very annoying, but it was fine. Whatever.
Mm-hmm. How many shops do you think you've been to in your time as a freelance guy?
Probably about at least over 100 for sure. I've done work for 100. It looks like, and that means I've been to like much over 100 shops.
What are some of the most common things you see those shops doing wrong?
Doing wrong? Well, that depends on what you define as wrong,
Yeah.
because I would say that if you're making money, then you're doing something right, improper is probably a way, or like unconventional, but there are a lot of people that's like they could be making a lot more money, but they're being dummies. But like
Well-
at the same time, it's really hard to change when it's working,
Right.
So
I guess to rephrase that, what would you say is some of the most common like low hanging fruit?
no tool library, no fixture library, shit cam systems. Not cam systems as in like, oh, they're using fucking Bobcat cam type of shit.
Right.
Like more like they have like every time a programmer fires up a part, they're building tools from scratch. They're bringing in work holding from scratch. It's like doing like parts that they've done like a million times. They have no templates for, and it's like, what are you guys doing? Like no tool library at all. And some people, like, again, this is like one of those things that people like they're in the pursuit of perfection before even starting. Like I've talked to guys like this where they're like, well, I'm always thinking about how to do something better. It's like, but you haven't done anything yet. So like, what are you talking about? Like just do something and then improve upon it.
Yeah. And that's an easy loop to get caught in. I definitely get caught in it too.
Everybody does.
Yeah. I think one of the best sayings I've heard in relation to trying to be perfect is don't let perfect be the enemy of good.
Yeah.
That's something to keep in mind, because it's really easy to, chase down perfection, and then basically you don't even get started because you're too worried about trying to do everything right to get there.
There's this kid in Arizona, love him to death, but like I've yelled at him so fucking much, it's out of control. And the last like hour-long rant I went on, he was like, he called me like a few weeks later, and he was like, brother, thanks. He's like, I'm doing stuff so much faster now, because he would just like without cutting anything, he's just trying to like like, oh, it's gonna do this and it's gonna do that, and I just like, and he's like spinning out and like totally crashing out without having cut a single fucking chip,
Yeah.
you know? And it's like, dude, just fucking cut. Like, I don't know what's gonna happen. You don't know what's gonna happen. This fucking guy you're talking to in Florida, he also doesn't know what's gonna happen. How we're gonna know is by cutting,
Right.
right? So like, just fucking cut some parts and see what happens.
So some of the stuff
Like,
he's worried about, like how a part's gonna warp and stuff like that, or
right. Yeah, exactly. And so it gets to this point of like, it's like, dude, just fucking cut some chips. Um, and he's like, yeah, you know what? You're right. You're right. Like I just started cutting stuff and I get through stuff a lot quicker now. Like the one, he's like, oh, I'm drilling these parts and I have like a 1 thou linear tolerance, not a 1 thou true position. Or plus or minus 1 thou linear. And I was like, okay, are you spotting? And it's in stainless. And he's like, no, my friend said I shouldn't need to. And it's like, well, fucking spot. Like, there's a place locally to you, like literally right around the corner that'll get you a spot drill. Go get a spot drill. So he did. And this is another one where he's like, he spotted, we changed some other things. He's making good parts. And he's like, well, they're good, but they could be better. And it's like, okay, so like, are you still cutting? And he's like, well, I just need it to be better. It's like, why? The customer doesn't fucking care.
yeah.
Like you're trying to make your good part more good. Like, who fucking cares, man?
Tolerance is intolerance.
Yeah, exactly. Hashtag within tolerance. Listen to the podcast.
Nice.
It's just like at a certain point, like I think it's ISO, the most recent ISO, like ISO 2015, had a real big focus on like value add to the customer, you know, and like making a good part better does nothing for the customer. If you make a slightly better part, but it's late because you spent time making your part be from 8/10 out of position to 5/10 out of position, like, okay,
Well, and
like if that doesn't work for them, then their print fucking sucks and that's their fault.
yeah.
But if your part meets print and it doesn't work, that's not you, man. Like, fuck them.
Well, and what he was trying to do there is a perfect example of that expression I said of don't let perfect be the enemy.
Right.
I mean,
Yeah.
you're good already, and that good that you're at is good enough for the customer. Don't try to be perfect. Leave it at that 90% perfection rate. You know, like you're 90% on the way to perfect. Just stop there. It's okay.
Yeah.
The last big 10 of trying to chase perfect is what's going to bite you in the ass.
Yeah, exactly. It's also why like I think like my advocacy for like any system like is to not go for like the most dialed in shit you could possibly have, but like I just throw out like 80% because I like the 80/20 rule.
Yeah.
Is just like how do I get to 80% of optimized like as fast as possible and like getting that part on the machine as fast as possible. And if I need to improve, like say I'm doing production work, I can do that while I'm cutting chips. There's nothing stopping me. If I spend 2 days to try and squeeze 15 minutes out of a fucking program, like I could have been making parts that whole time.
Yep.
Why would I do that? You know? That was the thing last night when I was with these guys. They're like, just give us the post. And it's like, we're going to start cutting first. We're going to cut first and we're going to get that machine running. And then I'm going to set you up to do this yourself. And that's what we did. And like the guy was standing with me while his programmer was running the parts. And it's like, see, like, this is why you do it. Cause now we get to fuck around with things. And like, we wouldn't have found all the dumb bullshit that we did find with the offsets.
Yeah.
If we had started with the post and getting him set up and spent like 2 hours dialing that in to then get to the machine to find, oh, it doesn't work because you set this thing up incorrectly. Switch the order of operations, get cutting first, dial everything else in second.
Yeah. No, I like that concept, and that's something I could do more of.
Yeah, it's an engineering triage. It's engineering or manufacturing triage, which is you have like your right solution and your solution right now. And in like 99% of the time, the solution right now is the one that you should be doing, because that will get you, that's your quickest path to success in the moment. And then you can fix it later. that is hard to like jump sometimes to like go back, but whatever, you'll figure that out. It's all process. It's all process.
Yeah. Almost all my big rough out parts, I just use a 3-axis volume mill. It's a quick one operation program.
Yeah.
Throw that in the machine. It's gonna run for a couple hours. Then I'll go fine tune the rest of the shit. Let it run.
Yeah, dude. I do the same shit. But with mostly like Fusion is like 3D adaptive, or Mastercam is like is OptiRough, the dynamic, and like just let it fucking eat.
And them operations are proven. They fucking work. They're predictable. You know it's gonna work. So just throw it in there, get it going.
Yeah.
I've had
Get
to
her
get
popping, baby.
I've had to get accustomed to that thinking, because the shop I came from, I mean, I was programming for other people, and those people didn't necessarily, they didn't do anything as far as tweaking a part to run well. So now here in my new job, I mean, I'm programming the part and running it, and I tell you, I'm a week in, and it's actually been a little hard to get used to the idea of, okay, just get it running, get 20, 30 minutes of roughing going, or an hour of roughing going, and then come back and work on the rest of it. Or even get another part on another machine, and then you can start finishing everything else. I'm getting there. But the guy I'm working with is like, you're going to have to learn how to work how Brad works, okay?
Yeah.
You got to have trust in your process.
Yeah.
If you don't trust your process, you got to fix it.
Yeah.
Right.
I completely agree.
Speaking of processes, wait.
And take your time to, dial in your cam, whatever you use it. Use it.
Yes.
Make it work for you.
Yeah, I mean, well, because I talk about it a lot, and I think Brad talks about it a lot in that like group chat or whatever, which is like you advocate. I think you improperly advocate for CamWorks. Not that it's bad; it's just that you don't give yourself enough credit for the system that you built over the last 10 years to make your life easier. So I think Fusion or a couple other ones would be able to do it now. I think CamWorks was doing it the best back then. Especially because like it is like lore from way back of people doing like really cool automated shit with CamWorks. I think the industry's like finally caught up. Like you can do some really cool shit in Fusion. But it is like when you get to that point of being able to like essentially like click, 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 I have a part that's pretty good, and you can just throw it on there and run it with like extreme confidence is something that is great and a goal. And it is hard for people to because it can take months or years to dial it in, and it's never ever done. Like I've had customers where it's like, we will get to this point, but they hear that, or I say it incorrectly, and they think we're going to start there. But I've done it like a customer in Pennsylvania with a 5-axis, a Haberly, and it took a little while, but we got to the point with like their part families and it's specific to them, that we have like the tooling dialed, the speeds and feeds are dialed, the process is dialed, and it's like, oh, I need this part. Okay, give me like an hour, boom. And they're confident enough with my shit that it's like they just run it, But it took like 6 months for us to like really work out all the kinks of that. I mean, we could probably do it faster if I was on site, but like the aspect of it being remote, like you get Brad, I'm sure you were getting like more instant feedback on what worked and what didn't, and were able to like tweak it live. And I think part of it, like Cam, like an easy way to get into this and like start is just like, if you think about it, like I'm going to take 15 minutes extra per program, like you have the time, it's there, right? If you just take a little bit of time per program every time to just like, I'm going to build this to be parametric, or I'm going to save this tool and like in these libraries and like right click, save these templates or whatever, this a little bit over and over again, is like, I mean, obviously it comes down to discipline, but like you just do a little bit over and over and over, and eventually you got a fucking system that's working for you.
Mine took years. I didn't jump in the tech DB for probably the first 6 years. I thought it was terrible. I couldn't figure it out for the life of me.
Right.
And then I overhauled it, and I spent some time in it, and it was just like you said, it was, I'd program a part and I'd go and I'd save it, and then I'd go and I'd fine tune it. And every part I did a different operation. And eventually over about a year period, I had a great library ready to go.
Mhm.
And I don't know. So I do credit CamWorks a lot for it just because I know how their TechDB works, and I haven't seen another software do it, but I know I've watched some SolidCam videos. I watched some Fusion videos, and there's some great templates in there that
Right.
I don't understand why people don't use them. Like you're just not efficient doing it.
Yeah.
But where I think CamWorks kind of stands out is, so like I use a lot for holes. I do a lot of helicoil inserts. So like I built like let's just say a 1/4-20 helicoil insert. It's a 266 H drill. My soft will recognize that helicoil. It'll pull in, I think it'll pull in a 3/8 120 spot drill. It'll put the 325 diameter spot drill on it, the 120, and then it'll pull in the 266 drill, and then the correct helicoil tap. It does it all on its own.
Yeah.
And I know I've heard some people say NX can do that, but I've never watched any of that.
Yeah, NX can do it. You can do it with Hypermill too.
Yep.
Hypermill has some like crazy good automation. Like their automation center is kind of disgusting with how good it is. And like Fusion, you can get pretty close to that,
Yep.
And I think even with I don't know. I don't really do a lot of like auto recognition stuff, but it's like you can pull in the template, and then it's like you'd select like one hole, and then it would just do the rest of them, kind of thing,
Yep.
and you'd be good to go.
Yeah.
So it's like it's obviously not like super automatic. Like it being part of SolidWorks, like this is one of the things that kind of blows about Fusion is they don't have, at least the last time I was using it, like very recently, like they just don't have like STI stuff in there. So you kind of have to like fake it a little bit for STI. But that being said, like a hole is a hole, so I wouldn't recognize that it's a hole. But you select the hole, even if it's a 1/4-20 and you're doing like 1/4-20 STI, it'll blow that hole out. It doesn't care. It'll be fine.
Yeah. And the other thing with CamWorks, like if you got like in the TechDB, if you got like, you can build in processes like a rectangle pocket. You can tell them, the box width, if it's less than greater than, grab this tool. If it's deeper than 3 inches, grab this tool.
Yeah.
Grab that tool. I want you to step down this, this flute length down. And then it's all controlled by, your feeds and speeds. And then you select your material as well. So if you take a part and it's aluminum and you change the material to 1018, it's going to adjust all that based on your TechDB automatically.
Right. Yeah.
And
That's cool.
it takes a long ass time to do it. I haven't gotten that in depth with some of it, because some of it's like largest inscribable circle. If this tool can fit in here, we're going to grab this tool, and then you can break it down into every drill size within 2 thou. It's kind of ridiculous, but if you really get into it, it's really helpful.
Yeah. Yeah, and you're making it work.
Yeah.
And really, I guess part of that whole thing, or this whole thing, is like anybody could make it work for like just about any software. Like you don't need to switch softwares is to make it work. You just need to start doing something, anything really. Like a tool library is better than no tool library, like 100% of cases. Even if it's kind of like trash, like, oh, I have like all these tools set up, and they're just like sitting on a cart or whatever. Like if you know that you have them and you can build it reliably and it makes your programming faster and your setup faster, I think that's another thing I do want to touch on, which is some people build their systems so that the programming is easier, but the setup person has to do a lot more work. Or like, oh, my Pocket 9 is for an 1/8 inch end mill, and the length of stick out of that end mill will change, and the setup person just has to be like really dialed in. I fucking hate that.
Yeah.
I don't like that. I would prefer to have 10 1/8 inch end mills set up that at varying lengths that are assigned to different pockets, as opposed to having one that is variable all the time. Just because like Like obviously there's more money and there's downsides to that, blah blah blah, whatever. But if my life is easier and the setup person's easier, that means the part's going to get made faster and better, and then it's going to ship faster,
And less
which is
less crashes. Let's call
right.
it nuts hitting your part.
Yep, exactly. Because it just takes like one person not paying attention, and then all of a sudden you're fucking
Exactly.
cooked.
I like it, the
Um,
mistake proofing aspect of it.
yeah,
That
yeah,
at my last job, that was something that I started doing. So we had a
yeah.
standard list in all our mills, like 1 through 10 was locked in, typically the same stick out, same tool, all that. And if I needed years ago, if I needed like tool 7 was a 1/4 inch by 3/4 end mill, if I needed that to stick out or be necked or whatever, I just
Mhm.
changed tool 7 out because it was easier for me. But I got to thinking,
Right.
even though I would write out a setup sheet and I would put that in the notes, okay, it would be easy to glance that over because the operator's going to see, oh, that's tool 7. It's in there. It's good to go.
Yeah.
But so I
Yeah.
started, okay, even if it's the exact same tool, if it needs anything different, even a stick out, that's going to be
Mhm.
tool 11 or 12 or 13 or whatever. Something
Right.
odd that they have
Right.
to build and put in.
Yeah. Yeah, exactly. Because I went through that exercise myself with this same customer in Pennsylvania. It's like, hey, this tool is sticking out this much currently. I need it to stick out this much. And I just said it over and over and over again. And the to the point where they're like, I'm kind of concerned that you're saying this. It's like, well, I'm saying it because if you overlook it, you're gonna crash. Like,
Mhm.
and I just don't want to crash. So then yeah, it's like, oh, if I'm sticking a 1/4 inch chamfer tool out a 1/2 an inch longer, yeah, now it's just plus 100, whatever. Just
Mhm.
give it something else. Then it's, easy peasy. If they want to standardize and make the other one just longer, they can tell me that, but we're just gonna assign it a different tool and we'll figure it out from there.
Mhm.
And that's another thing is like the system's fluid, it's
Mhm.
not like you lock it in once. I'm sure, Brad, you fucking done this a bajillion times where you're like, you know what? I don't like how I did this. I'm tearing it down, I'm rebuilding it.
Yep, I do it all
Um,
the time.
yeah. Like one of the things like in Fusion, they have like the model, and then they have what's a little section that's not there until you create it, but called the NC program, and then your setups. And the NC program allows you to select multiple setups if you want, you know? So what I'll do is, I have these 3 parts that are like a good example is a rail for like a Picatinny rail that has different MOAs. So the angles are slightly different. And in the first operation, the only difference is that they like the fucking counterbores to be at the MOA. So everything else is the same. So I have the main setup is the entire program minus the counterbores, and then 3 additional setups each for the different counterbores. And so I'm not redoing if I have to redo it, I'm not redoing every single one of those parts if I make a change. The main change happens to all 3 all at once. And same thing, and then the second ops will be different because there's more shit going on with it, but I can have like a very common first operation, and then like you just have the different NCs selecting different setups. So when you make adjustments, it's just universal, which is
So
an
you're
incredible feature.
grabbing setup 1, which is all your basic stuff, and then you're grabbing a follow-on setup to go with it.
Yep.
Would you be an advocate for companies to repost every program out or save NC files?
Both, I guess. So if a program is if I'm making edits, like I it's interesting because like on mill turns, like multi-spindle, multi-turret stuff, like I don't really like reposting a lot because there's always a bunch of like little hand edits that end up happening. So I'm copying and pasting code in there.
Yep.
So that is like just save the fucking NC files
Yeah.
because it's way easier. Um, on mill stuff, if I'm making changes, I hate when my cam and my NC don't match.
Yeah.
So if I need to make a change, I'll repost
Yeah.
and just always repost. But once it's dialed and it's good, then I'm fine. Then we're fine. It's like unless we're making changes at that point, then we don't need to repost. Just keep it in there.
That makes sense. If you what's your preferred cam system?
Depends, you know. I like for my machine and everything, I use Fusion. It's like I just have I I mean, I have it. A lot of my customers have it, so I use that. The parametric aspect of it makes it really easy to like have like my Kurt Vise or inverted jaw Kurt Vise and like just like dropping shit in and like being able to like fire up programs like fixtures really quickly. But I also use Mastercam, we use Esprit, we use Inventor, we've started using Hypermill. Just kind of depends on what we're doing. But I think like if somebody doesn't have a software that we use, I'm doing it in Fusion like 10 times out of 10 because it's cheap and effective. And it integrates with Camplete well. So like if somebody is using like GibbsCam and they're like, oh, I want you to program for me. It's like, I don't have GibbsCam. I'm not going to fucking buy it either. So if you want it, I'll do it in Fusion. And they're typically like, okay with that. And then if they want the file, they don't have to spend like $750 and then they have it, you know?
Yep.
And that's
Is that pretty typical that you'll program something and then do they want the file?
Sometimes like that's a big thing. Like for the most part, we give them like code solutions, but if they want to tweak things themselves, we'll give them the file. Though in most cases, honestly, that like we'll give them the file and then they'll still ask us to tweak it.
Yep.
Nah,
You ever have any issues with customers paying?
all the time. Yeah, all the time.
Oh,
I legit have 6 figures in accounts receivable right now. Like it's out of control. And you're just like, it's a lot of it is for like work we've already done. So it's like, it drives me fucking crazy.
You do net terms with these customers?
15, but everybody's at like 30 days right now. Yeah.
so what do you do?
Yeah. Huh?
What do you do?
Just bug them, bug them until I get paid. There's not really much you can do. Like at a certain point, like if the money isn't high enough, like there's a kind of a threshold of like if it's below like 50 grand, it's kind of not worth suing somebody over.
Right.
Yep.
You know? So
You're going to
like,
end up settling for 5.
yeah.
And you're going to have more in attorney fees doing that.
Yeah. It's just not like, so you just, people do pay. They pay eventually. It's just they'll fucking string you out as long as you'll let them.
Yeah. Well, it was good having you on, man. It was nice talking to you.
That's just fun.
Yeah.
Yeah.
I guess we'll have to have you on again. Maybe you just go full-time podcaster.
Right?
Yeah, right. I mean, I don't have any problem screaming into a microphone.
Yeah.
So it's pretty fun. I talk way too much. Of all the people that I know, like at IMTS, I was the only one that like didn't lose my voice. So I'm like, oh, that's saying something. This guy doesn't. Chris Zappettini, baby.
All right. Where all can everybody find you, Chris?
Consulting on Instagram, and with Intolerance, I'm on there every other week. We just had an episode 250 just dropped where it was Dylan and I chatting, and we have like some book club episodes coming up.
Sweet.
So I'm on there, and that's kind of the 2 places. And then I guess just recently the Chips and Tips podcast for Toolpath, we just did that one. That one just dropped recently, and previously like Manufacturing Happy Hour podcast or whatever was on that bad boy.
Awesome.
Fun.
Well, as always, if you liked it, like it. If you got something to say, comment. If you really like it, then subscribe. That'd be cool too. Yeah, appreciate
That'd be pretty
watching wherever you are. And we'll catch you next time.